Okay, today I'll be explaining 14.1 and 14.2. First, 14.1 refraction. Now, as you can see here in this diagram, we have, first of all, the medium is air here, so and the medium here is glass. So when the ray hits the surface, it hits it with a bigger angle, then it refracts it with a smaller angle, which is, so this is like the angle of incidence, and this is the angle of refraction, sorry. And then here, as you can see, it's the opposite. So here we have the medium is glass, and the medium here is air. So here, when it the ray hits the surface, it hits it with a smaller angle, but then it refracts it with a bigger angle. So angle of incidence and angle of refraction. Now we have something called the index of refraction. Now it is, we could represent it by n. It's n equals to c over v. So c is the speed of light in a vacuum, and v is the speed of light in a medium. So we could say like n air equals to c over v air, and water equals to c over v water, and glass equals to c over v glass. And something that we could always know that n, the n of air is always equal to 1. Now here we have, whenever the angle is small, or the smaller the angle, the more the volume. Now directly, the more the volume, that means it's the less the density, and then the less the index of refraction. And then the opposite, the smaller the angle, the less the volume, the more the index of refraction, which is the n, and then the more the density. Because you see, as in this first situation, when like more volume, so there's like more spaces. Okay, that's like for example in air. So this example is like for in air, but this example is like in glass, because the particles are like really close stuck to each other, so the volume is less and there's more density. So we could say here air, and then we could say here glass, as in this is gas and this is a solid, or we could say also water. Now, refraction. So refraction is the bending of light when it passes through two media. And why is that? It's due to the change of light speed, yeah. So now we have the same thing here in the diagram. So I said when it hits the surface with a bigger angle, which is the angle of incidence, the volume here is more, and the index of refraction is less. And then here, when it refracts with a smaller angle, the volume is less, and the index of refraction is larger. So, and the same thing here, so it hits the surface with a smaller angle, so the V is less and the N is more. So here when it refracts with a bigger angle, the V is more and the N is less, which is the index of refraction. Now, so here, the refraction is near to normal, so the angle of incidence is smaller than the angle of refraction. And then we have here refraction is away from the normal. So the refraction here is away from the normal, so the angle of incidence is smaller than the angle of refraction. Now, why is all of this? That's due to the index of refraction. Now, what is the index of refraction? The index of refraction is a ratio between speed of light in a vacuum to speed of light in a medium. That is represented by, like, the equation is like n equals to c over v, and there's no unit for that. Now, refraction near to the normal is from low to high. Refraction away from the normal is from high to low. So n is like indirectly proportional to the v medium. That's because the more the n, the less the volume, the less the n, the more the volume. So yeah, and then we have the n air is less than the n water, less than the n oil, and then we have the angle of air is more than the angle of water, more than the angle of oil. So as you can see here, when it hits the surface, so when it hits, so as you can see here, so when this angle of refraction here, so we'll draw another line here, which, and then it will refract a smaller angle, which is the angle of refraction. So here, this is the theta, okay, the theta I, and then we would put the theta R more like here, okay? So then the formula is Ni times sine theta I equals to Nr times sine theta R, and that's the equation that we're going to use in the practices of section 14.1. So the angle here is 38.6 degrees. Now let's move to more practices. So here we have, first of all, let's do A. So A, flint of glass. So whenever they say from medium, know that this is the I angle, like the incidence, and then to medium is the refraction. So first of all, flint glass, we have it here given, which is 1.66, and then we have crown glass, which is also given 1.52. Okay, now, so when I will apply the formula Ni sine theta I equals to Nr sine theta R. So the Ni is the flint glass, so let's put the givens. Ni flint glass, which is 1.66, and then the Nr, which is the crown glass, which is 1.52. So N, and the angle here is, the angle given here is the angle of incidence, which is 25 degrees. So now we have all the givens, and we have to find the sine theta R, which is the angle of refraction. So we apply 1.66 times sine and R, which is 1.52, times sine theta R, which we need to find. So 1 times sine 25, which is 0.71, and then 1.52 times sine theta R. So we divide. So sine theta R equals to 0.701 over 1.52. So the answer is 0.461. So sine inverse and the answer is for the angle, it's 27.4 degrees. So that's the answer. Now let's do the B. So the B, now we have air, as we always said, it's equals to 1 and equals to 1 here. So we have here the Ni, which is the air, okay, is equal to 1, and then we need to find the Nr, and we have the two angles given, the theta of I and the theta of R. The theta of I is 14.5 degrees, and the theta of R is 9.80 degrees. So let's apply the formula. So the Ni of air, which is 1 times sine theta of I, which is 14.5 degrees, equals to the Nr, which we need to find, and then the sine theta R, which is sine 9.80 degrees. So we'll divide. So Nr will be 1, which is sine 14.5 degrees, over sine 9.80 degrees. So the answer of R will be the answer is 1.47. So there's no unit here. Now let's move on fast to the C. So the C, again, we have that the Ni of air equals to 1, and then we have the Nr of diamond. So we see it here. It will be given, so 2.419, and then we have the theta of I is given, which is 31.6 degrees, and then the theta of R, which is what we need to find. So I apply the formula. So the Ni, which is 1 times the sine theta I, which is 31.6 degrees, equals to the Nr, which is 2.419 times the sine theta R. So this will be like sine times 1, so it will be sine 31.6. So sine theta R would be sine 31.6 over 2.419. So it will be 0.216. So sine inverse 0.216 equal to 12.5 degree. So that's the answer. So that's it from section 14.1 refraction, and now we'll begin with 14.2 thin lenses. So here in the thin lenses we have two types. We have, first of all, the concave lenses, and then we have the convex lenses. So first of all, in the concave lenses, it's the rays that diverge, but then in the convex lenses are rays that converge. And in the concave lenses we have one case, and in the convex lenses we have 5 cases. So in real life here it looks like this, the convex lenses, and then here for the concave lenses it looks like this. So now the focal length is the image distance for an infinite object distance. Now we have, let's start first of all with the convex lenses. Let's start first with the 5 cases. So the first case is, so we have 2f and f, and this is the center. So the first case is before the 2f, so we'll draw the object here, and then we'll draw a parallel line. So it will refract here, okay, through the focal point and then to here. And then we draw another ray, so it will refract back here, okay, and then like that. So the meeting point will be here, so the image will be here. So yeah, so this is the image and it's real and inverted. The second case, it's on the 2f, so we'll draw the object, and then we'll draw the parallel line, so then it will refract through the focal point, and then we'll draw another one, and then here it will also refract back where a meeting point where the image is formed. So it's here, it's also real and inverted. Now we have the third case. Now here we draw the object between 2f and f, okay, so then we draw a parallel line, so it will refract back through the focal point to here, and then we'll draw another array that will also through the center, and then we'll reflect back here, and then this is in case like an extra one, so it will go through the focal point, another one, so another ray that will refract to here, so the image will be formed here. So it will be real and inverted and also like flip. So which is in, yeah, so sorry, it will be real and inverted. And it will also be bigger. Now we have the fourth case where we draw the object at the focal point, and then we draw a parallel line, so it will refract back through the focal point, and then we'll draw another ray here which will go through the center, and then it will also refract back, but here the rays will not meet, so it's like an infinity, and so the result is that there's no image. And then finally the fifth case, which is we will draw this is the focal point, so we'll draw so we'll draw, this is the object, so this is the object here. Okay, and when we draw the object, so it will release rays that will be parallel, so it will refract back here through the focal point, but then we're going to draw dotted lines from here to here, connected till here, okay, and then for the same thing for this, when we draw the ray, and it will go through the center, okay, and then it'll go through here, so also do dotted lines with that will go here, and also for the the ray that will be drawn here on the tip of the object, okay, so it will also release those dotted lines, okay, so when you draw it like that, okay, so it will also release some dotted lines, so here will be the point where the image will be formed, okay, so it will be like upright, virtual, and also larger. So know that like when the image is formed behind the mirror, it's real, and notice that when the image is formed in front of the mirror, it's virtual. Now we have the concave lenses. Now the concave lenses here, the rays diverge, which they do not meet in a focal point. So first we'll draw So for the case for this one, let's check where is the focal point. This is the focal point, yeah. Okay, so now back to the concave lenses. So the rays here will diverge. So we draw the object in front of the focal point. So then it will reproduce a ray that will diverge. Okay, it will diverge. So when it diverges, we'll draw a line, dotted lines that will go through the focal point, and then we'll draw another ray that will refract back parallel behind the mirror. Then behind the lens. And then we have the last one, the last ray. So it will go through the center, and then the image will be formed here. It's where the rays meet. Okay, but here it's not like the focal point, but yeah, so the image is formed here. Okay, and the same thing, it will be drawn a ray that will be parallel, and then behind the mirror, behind the lenses, it will refract. So lenses, not mirrors. Now we have the thin lens equation, which is 1 over p plus 1 over q equals to 1 over f, and the magnification of a lens. So it's m equals to h prime, which is the height of the image, over the h, which is the height of the object, equals to negative q over p. And we also have this table, which to know the signs of the p, q, and f. Now let's begin with the practices. First of all, we have the object is placed. So here we have the object. So an object is placed 20 centimeters in front of a converging lens of a focal length 10 centimeters, and so they're asking to find the image distance and the magnification to describe the image, like they're asking if it's going to be upright, inverted, real, or virtual. Okay. So let's start and take out the givens. So here we have the given is, first of all, an object placed in front of the mirror. So this is the P. So the given is, first of all, P, which is 20 centimeters. And then we have a focal length, which is F equals to 10 centimeters. So we'll use the formula, which is 1 over 1P, 1 over 1Q equals to 1 over F. So we don't have the Q, so we have to find the, so 1 over Q equals to 1 over F minus 1 over P. So 1 over Q equals to 1 over F, which is 10, okay, minus 1 over P, which is 20. So the answer would be the answer would be 1 over 20. So now let's flip. So when it flips, it will be just 20. So that's the Q. So now let's find the magnification. Negative Q over P. So negative Q, which is 20, over the P, which is also 20. So the answer would be M equals to negative 1. So here the image is real and inverted. Moving on to the second question, Sherlock Holmes examines a clue by holding his magnifying glass at arm's length and 10 centimeters away from an object. Now the magnifying glass has a focal length of 15 centimeters. Find the image distance and the magnification, and then describe the image that he observes. So first of all, let's take out the givens. So P here, sorry. So the givens here are P equals to 10, and then the focal, which is 15 centimeters. So 1 over P plus 1 over Q equals to 1 over F. So we need to find the 1 over Q, 1 over F minus 1 over p. So 1 over 15 minus 1 over 10. So it will be negative 1 over 30. So the answer is Q equals to negative 30. We flip, and then we have negative 30 centimeters. So now let's find the magnification. So negative Q over P. So negative على negative on على negative is positive. So so it's gonna be just 30 over the P, which is 10. So the answer, the magnification is 3. So here the image is, as you can see, it's more than 1. So it is virtual and upright. So let's just say m equals to 3. So now number 3. The givens are, let's read. An object is placed 20 centimeters in front of a diverging lens of focal length 10 centimeters. Find the image distance and the magnification, and then describe the image. So the first given here is 20 centimeters. So P equals to 20 centimeters, and F here it's negative 10 because diverging, this is diverging lens. So F equals to negative 10, and the P is equals to 20 centimeters. So these are the givens. Now let's use the formula 1 over P plus 1 over Q equals to 1 over F. So 1 over Q equals to 1 over F minus 1 over P. So 1 over negative 10 minus 1 over 20. So the answer is negative 3 over 20. So let's just cross multiply 1 over Q equals to negative 3 to make sure. So then the answer here, Q would be 20 divided by negative 3, which is negative 6.66. Just keep this here, more space. So we'll continue here. The Q would be negative 6.66. So okay, so continuing 666. So now let's find the magnification, negative Q over P. So negative on negative, it will cancel each other. So it will just be 6.66, okay, over the P, which is 20. So the answer is 0.333. So here the image is virtual and upright. Okay. Now let's do this practice. Final one. Okay, now let's start. So let's first start with doing A. Okay, so first A, so do not get confused. So this is like in the converging lens, and this is in the diverging lens. So let's first do A. So A is giving that the Q, we have the F, which is 6 centimeters. We have the Q, which is -3 centimeters. We have to find the P and we have to find the M. So let's use this formula to find the P and the M. So 1 over P plus 1 over Q equals to 1 over F. So 1 over P equals to 1 over F minus 1 over Q. So 1 over P equals to 1 over F, which is 1/6. So minus, okay, and then let's just do this, -1 over 3. So the answer would be (1 over 2). So P would be 2. Now let's find the magnification. Negative Q, which is -3. So -1, negative will cancel each other. So 3 over P, which is 2. So 3.2, which is 1.5. And that's the answer. That's the magnification. Now let's go and start with B. So B given here that it is F equals to 2.9 centimeters. Have to find the P. So we go to B. So F equals to 2.9 centimeters. We have to find the P, and the Q is 7 centimeters. So here we also have to find the magnification. So we use the formula 1 over P equals to, 1 over P plus 1 over Q equals to 1 over F. 1 over P, so here we have to find the P, so 1 over P equals to 1 over F minus 1 over Q. So 1 over F, which is 2.9 minus 1 over 7. So the answer would be it would be 0.201. Okay, so now let's flip it. So when we flip it, P would be 1 over 0.201, so we have to divide. So the answer would be 4.97 centimeters. So that's the P. Now let's find the magnification. So negative Q over P. So negative Q, which is negative Q, so -7. So here we don't have negative, so it's not going to cancel each other. And then we have the P, which is 4.97. So the answer would be -1.4. So that's the magnification. Now let's move on to C. So C, let's find out the givens. The F is -6 centimeters. The P is 4 centimeters. So here we have to find the Q and the M. So we use the 1 over P plus 1 over Q equals to 1 over F. So we have to find 1 over Q. So 1 over Q equals to 1 over F minus 1 over P. So 1 over -6. Okay. Minus 1 over P, which is 1 over 4. So the answer would be -5 over 12. So the Q would be flipped, so it would be -12. So the negative, so 12 divided by 5. So 2.4 centimeters. Now let's find the magnification. So M will be -Q over P. So negative q over p. So the q here is negative, so then negative here, so they will cancel each other. So 2.4 over the p, which is 4. So 2.4 divided by 4, which is 0.6. So the m is 0.6. Now let's go finally to the last one, d. Now d, the givens are, we have to find the f. Then we have the p is 5. We have to find the q, and then we have to find the m. So now let's use this formula. 1 over p plus 1 over q equals to 1 over f. So 1 over p is 1 over 5 plus, sorry, wait, check the givens again. Sorry, the magnification is given already. Magnification is 0.50. So now let's go back to the equation of the m, which is negative q over p. So to find q, let's do this. So it will be so we cross multiply, and you get that the equation would be for q, it will be negative m times p. So q would be negative m, which is 0.50, times the p, which is 5. So negative 0.50 times the 5 would be negative 2.5. So now that's the q. Okay, so that's the q. Now we need to find the f, so we'll use the formula again. 1 over p plus 1 over q equals to 1 over f. So 1 over p, which is p is 5, plus 1 over q, which is negative 1 over 2.5 to 1 over f. So 1 over f will equal to so the answer is negative 0.2. So if we flip it, f would be negative 1 over 0.2. So the answer would be negative 5, and that's the focal point. So that's it for this lesson and for both lessons, and thank you, and I hope you enjoyed and you understand. Thank you.